Throughout the course of history, man has come up with many unusual ways to demonstrate his strength. With all these remarkable feats of strength, to date, no one has attempted to catch a semi-tractor. But did you know 1 cubic yard of soil weighs approximately 1.5 tons, the same as a semi-tractor? Working below ground level in an excavation or trench can expose you to many potential hazards. Cave-in accidents are one of the leading causes of death and injury at excavation and trenching job sites. By understanding and respecting the potential hazards and following safe work practices, you can ensure not only your own safety, but that of your coworkers too. In this program, we will discuss how to plan your excavation and how to work safely in a trench, including the potential hazards involved in excavation, how to protect yourself from potential hazards, and safe work practices for excavation. There are 2 main hazards associated with excavation and trenching: contact with utility lines and cave-ins or ground slides. When planning an excavation, you should always check with utility companies to determine the location of all lines at least 24 hours before opening the excavation. Most utilities have a person or office that will provide this information. It is best to have the utility companies mark the location of their lines. When boomed equipment is used for excavation, you must have a minimum 10-foot clearance from the boom to overhead electric lines. Electric utilities are not the only potential hazard. Water, steam, gas, or sewer lines may create additional potential hazards, such as flooding, explosion, fire, or hazardous gas leakage. Make sure all these lines are either shut off by the utility companies or that extreme caution is used when working around them. It is important to recognize, too, that when underground utilities are in your excavation site, the ground will be less stable than undisturbed soil. As mentioned earlier, cave-ins are a serious potential hazard. A cave-in is defined as a separation of soil or rock from the side of an excavation, or loss of soil from under a trench shield or support system in enough quantity to entrap, bury, or otherwise injure or immobilize a person. There are 4 primary causes of a cave-in: vibration, weight, water, and soil composition, or how the soil is made up. Vibration from construction equipment or street traffic can make relatively stable, compact soil come apart and cause a cave-in. You should be very alert to this danger when working near a well-traveled street. Every precaution should be taken to protect yourself in the trench, and you should keep careful watch of the surrounding area for cracks or other early warning signs of a cave-in. Keep heavy equipment far enough away from the edge of the excavation to make sure the vibration set up from their movement is not putting an additional strain on the trench walls. The weight of heavy equipment can also be a hazard if operated or stored too close to the trench opening. This additional weight can overload the trench walls and cause a cave-in, so keep heavy equipment well back from the edge of the trench. The weight of your spoil bank or the soil you've taken out of the trench can also be a hazard. As the spoil bank grows, the weight increases until excessive pressure is put on the trench walls, causing a cave-in. Plan ahead to keep the edge of your spoil bank at least 2 feet from the edge of the trench. The texture or cohesion of the soil is the key to how stable the soil will be as you are excavating. No matter how much experience you have excavating in your area, it's good to remember that every soil is different. No 2 jobs are the same, and every situation can be hazardous. Pay close attention to the soil you are working in. The soil should be tested by a registered engineer or a competent person before excavation begins to determine the soil composition. A competent person not only must be able to accurately identify soil types, but also must be familiar with the requirements of all federal and local safety standards and be experienced in the use of protective systems. And the competent person must have the authority to stop the job until corrective measures are taken to eliminate potential hazards. Generally, the more cohesive the soil is, the more it sticks together rather than crumbles. For example, a sandy soil can slide back into the trench since sand is not cohesive. On the other hand, solid rock, shale, or clay is very cohesive. As you excavate the trench, you may come across different soil consistencies along the length of the trench and at different depths. Remember, if the soil consistency changes, there is a hazard. For example, if a clay layer is resting on sand, it's possible for the sand to shift and undermine the trench wall, causing a cave-in. Water is another potential cause of a cave-in. Water from the surface, groundwater, or the moisture content in the soil itself may reduce the soil's strength and stability. Rain can also be a hazard, since it can make the banks of the trench collapse due to excess weight, or it can fill the trench with water. To prevent water from collecting, use a diversion ditch or a dike to channel the surface water away from the trench. Use a pump to keep rain or groundwater from collecting at the bottom of the trench. In addition to rain, an extreme change in temperature can make soil unstable. Usually frozen soil is very cohesive, but unfrozen soil below the frost line will be less cohesive, may undermine trench walls, and cause a cave-in. Also, freezing may expand the soil behind any shoring you may have in place or any soil piled near the edge of the trench. This can increase pressure on the trench walls and cause a cave-in. You may also be working as the soil thaws out. If this happens, be on the lookout for mudslides and cave-ins. And it's possible for heavy equipment to slide in the mud and topple into the trench. A lack of moisture in the soil can also be a hazard. Dry soil tends to crack and cause the trench walls to collapse. Remember, as the trench gets deeper, the likelihood of a cave-in is greater. Now let's take a look at how you can protect yourself from cave-ins. There are 3 cave-in protection systems available to you. They are sloping, shielding, and shoring. Remember, excavations of more than 5 feet deep in any type of soil must be provided with a protective system. And if a potential hazard is identified by a registered engineer or the competent person, excavations of less than 5 feet must also be protected. If there's enough room at the job site, an excellent way to protect yourself while excavating is by sloping your trench. The trench should be graded to the maximum allowable slope, the angle at which the soil will lie without moving. The maximum allowable slope will vary with different soils and will need to be determined for each job. If you're in doubt about the type of soil, it's better to make the angle as flat as possible. And when water is present, the angle must be even flatter. Sloping works best for shallow trenches requiring a small work area below the surface of the ground. It's very difficult for the untrained eye to measure this angle accurately. All measurements should be performed by a registered engineer or a competent person. Shielding is a structure that is able to withstand the forces of a cave-in and will protect the workers inside. The shield is a prefabricated movable box, usually made of metal. It's a good practice for the box to extend above ground level. If the shield is installed below ground level, the trench walls must be sloped to allow 18 inches of the shield to extend above the edge of the trench. The shield is moved along as work progresses, and the trench should be backfilled as soon as the work in a particular area is finished, so no one will go into an unshielded trench. It's important to remember that a shield is not designed to prevent cave-ins, since the shield ordinarily does not fit snugly against the walls of the trench. Workers are only protected as long as they are inside the shield. Shoring is a structure that supports the sides of an excavation and is designed to prevent cave-ins, since the shoring is placed tight against the trench walls. Shoring may consist of metal or timber, or a combination of both. Federal requirements must be used as the minimum accepted guidelines for both design and installation of the shoring system. A typical shoring system may have braces and uprights. Braces are the horizontal members of the system which hold the uprights together and prevent them from collapsing under pressure. Braces may be hydraulic, mechanical, pneumatic, or be made of timber. Uprights are the vertical members which may be in direct contact with the earth walls of the trench. The braces ensure that the uprights remain vertical. In some soil types, sheeting may be used to resist the lateral pressure of loose soil or water. The sheeting should extend above ground level to keep the spoil bank from sliding back into the trench. Wales or stringers may also be used in some applications. The entire shoring system must be tight. If there is any play or give, the shoring may collapse under pressure. Be sure to compact any loose soil placed behind the shoring to tighten it. After installing the shoring, it must be inspected in accordance with federal regulations by the competent person. While a shoring system will help to prevent a cave-in accident from occurring, there are other general practices to help you work safely around an excavation. In every trench over 4 feet deep, there must be a safe means of entry or exit, usually a ladder. Ladders must be placed so that an employee is within 25 feet of the ladder while in the excavation. And the ladder's side rails must extend at least 3 feet above ground level. All materials, tools, and equipment should be stored at least 2 feet away from the edge of the excavation to reduce the hazard to workers in the trench below. Never walk or stand under loads handled by any type of earth-moving equipment. Stay well away from any vehicle being loaded to ensure you won't be hit by any spills. When exposed to public vehicular traffic while working, wear a vest made of highly visible material and follow the requirements of your job site regarding the use of personal protective equipment. Air quality in deep trenches or excavations can also be a cause for concern. If you are working in a bell-bottomed excavation, you may be required to follow work practices developed for confined spaces. If you are excavating in or near an area with known hazardous waste, such as a landfill, you may need to follow procedures to monitor air quality regularly. Excavations should be provided with adequate protection at the edge of the excavation. One way to do this is by using proper barricades. Barricades should be 42 inches high and at least 5 feet back from the edge of the excavation. Though there can be many potential hazards associated with excavations, you can ensure your safety through awareness, respect, and by following safe work practices. Identify all potential utility lines before digging. Know the type of soil you are digging and utilize the proper measures to prevent cave-ins. And follow all safe work practices, including the use of personal protective equipment and escape routes in the event of an emergency. By utilizing the information and following the procedures presented in this program, you will avoid demonstrating your feats of strength below the ground.